can't stop. Area of regular polygons. Okay, a regular polygon is a enclosed shape with at least three sides and all sides are congruent. You can do the little congruent sign right there. And all angles are congruent.
Can we put all sides and angles?
Yeah, I wish I said that. All sides and angles are congruent. I wish I shortened it like that. Examples of regular polygons that we already know are squares. And depends on what kind of triangle you're talking about. Yeah, equilateral triangle. Equal. I'm just gonna simplify it there. Lateral. Dang it. I'll just try to spell it. Equilateral. Be quiet. Triangle. Okay, I can't think of another one. I want to say rhombus, but how come rhombus doesn't work? What's that? Angles are not all congruent, just the opposite ones. Okay? The center of a polygon is the center of a circumscribed circle.
What is that?
Circumscribed circle? I'll show you.
The center.
Okay, so a circumscribed circle for a polygon is one that you can draw all the way around it. It touches every single... Oh, dang it, that was a horrible circle. Okay, this is kind of hard for me right here. It touches every vertice, but the circle goes completely around the polygon. And so the center of the circle is also the center of the polygon. Okay, so that's important to know. The apothem is the perpendicular line that goes from the center to a side. Okay, that's this guy right here. I like drawing him dotted. Okay, perpendicular. I mean, you could write it like that, or you could go like this to like another side over here. Because my shape is kind of squished, I can't really do that. But I like drawing it straight down. That's perpendicular to the side. Okay, and finally, the radius is the line or lines that go from the center to a vertice. A vertice is the corner. So it'd be like this right here. It's also the radius of the circle. Okay, so and you know the radius could be there, it could be there. It's just it has to go from the center to a vertice. Label all your stuff here. Apothem, radius, center. All these things are very important when it comes to finding the area of this dude. Okay, so let's check out this. Oh wait, we're not doing this activity. We didn't do this activity. Hold on, let me wipe this out. Okay, let's draw ourselves. We're just gonna draw a pentagon. We're gonna look at how to find the area of a polygon. Now these are only regular polygons. They have to be regular polygons. Okay. No, it's a pretty good pentagon. Okay, now in order to find the area of this, we have to know at least one measurement, like the apothem or the side. My favorite problems are just like they give you that measurement and they say, okay, find the area of this dude. Okay, but let's not put 10. Let's put a X right there. Okay, now what you have to do here, we have to know the center. Yeah, I'm not doing the, because we didn't do the activity. So yeah, you could, yeah, does this say example? No, that, yeah, no, we're not going to do the example one. I'm just going to give you guys the formula right now. Okay, this is, so you can do this on the back, wherever it's blank, wherever you have space. This is formula for a regular polygon. Okay. That's right. It's the formula for the area of a regular polygon. Okay, so we have some measurements that we definitely need. We need to know what the radius is, and we need to know what the apothem is. Okay, and so this is the trick though. In order to find the area of this regular polygon, we're going to use triangles. Okay, I call this triangle right here the Apothem Triangle. I don't know if that's an academic term. I haven't seen it in a textbook yet, but I like that term because it means that you have to use the apothem for the height of this triangle. Okay, so this triangle right here, I'm going to call the Apothem Triangle. How many Apothem triangles are in this shape? Let's see. No, there's one. I see one red one right here. Here's 2. Here's 3. Here's 4. And here's 5. So there's 5 Apothem triangles in this. Now, can we just find the area of that triangle and then multiply by 5? Yeah, we can. That's how you would find the area of it. The area of this this whole shape, this pentagon. So the area of a triangle is 1/2 times base times height. In this case, we're going to say the area of this polygon is going to be 1/2 times the A, because the Apothem triangle, times the base, which is X. And then how many triangles is this? There's 5 triangles. And so we multiply this by 5. Or you can say the number of sides. Before we said the number of sides was n in a previous concept which relates to this. So we'll say right here n equals number of sides. That's how you find the area of a regular polygon. And I hate formulas, guys. I hate that. I'd rather you guys just think of this and go, oh yeah, that makes sense. If I find the area of that Apothem triangle, I can find the area of the whole shape. Okay? Now there's another formula that I can give you guys, but I don't like it. I don't like giving you guys formulas. Should I do it? Yeah, I should do it. Okay. This is what I don't like. If you're only going to memorize this, you're not getting very mathematical. The area of a polygon is the perimeter of the polygon. Well, actually, 1/2 the perimeter of the polygon times the apothem. And the reason why it's 1/2 the perimeter times the apothem, when you look up here, if you know how like multiplication doesn't matter the order you write it in. I can write this as n times or 1/2 n times a times x. All right, I just put the number in front. It doesn't matter the order because they're all just multiplying. There's no distributing going on. If you look at this, n times a. What is n times a? Or I'm sorry, n times x. What is n times x going to give us? If x is right here and there's 5 x's, 1, 2, 3, 4, 5, that would give you the perimeter, right? So n times x actually gives you the perimeter. That's why you can just say 1/2 the perimeter times the apothem. Now, if you remember all of that and you still like to use that, that's cool. I like that. Then you know, because you know where the formula came from, you have a better chance of remembering it. Check out this example. We're not actually going to find the area right now. We just want to label it. Let's see. It says find the angle measures. Or we're gonna find the angle measures. In the figure below, the pentagon with the radii and apothem drawn in. Highlight the okay. How are we gonna find the angle measures? I don't see any numbers here that represent an angle. All I see is, you know, these numbers right here. Well, one of these is really easy to find that we can find right off the bat, and I'm hoping you guys see it. Anybody, raise your hand if you see it. I want to see if you. Okay, well, 1, 2, 3, 4, 5, 6, 7. Ooh, okay. Angle 1 is going to be the easiest one to find right now. What do all of these angles, these different colors, this angle, this angle, this angle, and this angle, and this angle, what do all those angles add up to? 360 degrees. Okay, and how many of those are there? See, 1, 2, 3, 4, 5. There's 5 of them. So what's the measure of this angle going to be? What is it? 72. Yeah, 72. And we got that just by going 360 divided by 5, because there's 5 of those central angles. That's these guys right here. Central angle is 72. Oh, that's cool. Now, because we know that, we can find this. Now, why can we find that? Because this is perpendicular to the side, and it bisects the central angle. It splits it in half. Okay, let's use a different color for that. So if it splits it in half, what's the measure of angle 3? The measure of angle 3 is going to be 36. Oh, see, look, we're finding things without even having any numbers on the thing. Now, if that's 36, what's this going to be? Well, do you guys know what all the angles add up to inside of a triangle? 180. And do you guys know this angle? Faux show. So we got 36 plus 90 is going to be 6, and that's going to be 126. So, and I had to take 180 and subtract the 126, and you guys got 54, right? So the measure of angle 2 is 54. So it's possible. We can find angle measures without being given one of them. Okay. 360? Well, that's the. If I go all the way around this, that equals 360.
Oh, how'd you get 36?
36? I got 36 because the apothem bisects the central angle. The central angle is this blue angle. That blue angle is right here. That blue angle is 72. And so if this is bisected, you just have to divide it by 2 to find 3.
So you just divide 72 by...
I divide 72 by 2, yeah, to find it, the measure of angle 3. Yeah, now I got 36. Yeah, 72 divided by 2 is 36. And then to find 54, 36 plus 90 plus that number right there should add up to 180. So that's why we did this stuff right here.